I will talk about symbolic calculations in Python. You find extensive documentations online if you want to dive deeper into linear algebra. I strongly recommend installing SymPy using the pip installer. Furthermore, it is best practice to create and activate a virtual environment that will contain the installed library. I have done a few videos on that. The best way to navigate my content on YouTube is actually to use my GitHub repository. The link is down below in the description. Now, to create your environment, you just navigate to the folder where you want to work in. You type in cmd and it opens the command line. Of course, I'm on a Windows operating system. I type in Python -m fenv for virtual environment and then the name. You can use whatever you want, for instance sy or symbol or whatever, and you just execute that. So once this is done, it will take a few minutes. You just navigate to the name of your environment, in my case symbol. Then you go into scripts and then you go into activate, and this should activate your virtual environment. If that worked, you see in brackets in front of your prompt the name of the environment. And then you just use the pip installer. So it's pip install and then SymPy. And you execute that. I already installed that, and you just wait until this is done. It takes a few minutes. So once this is all done, you just leave this setting so you are in this activated environment. And now if you want to run Python scripts, you can just type in Python and the name of a script. We start with a usual import statement in line 4, then we declare the symbols. So line 7 tells Python that A and B are symbolic, and these symbols can be then used in a matrix. So matrix A would include A and B as two entries, and we can then simply print the matrix. We can also create a matrix like this matrix N here, which itself is just a symbol. And we can also change the shape. So in this case, it's a 2 times 2 matrix. And then I can simply run matrix operations on it. For instance, I can multiply matrix A and N, and I can also add here the inverse, which is a method I call on a matrix. So it's simply inv open close brackets. Finally, I can add, of course, more symbols like in a data matrix. So in this particular case, we have 4 observations and 2 independent variables. So we have a 4 by 2 matrix, and the symbols are then included in this data matrix. And then, of course, I can do operations on it. For instance, I can derive x transpose times x, which we also used in our calculation for the OLS estimator. Let me just run this. It's just Python, and I think it's matrix fun. And here we are. So we have done our symbolic calculations. So these symbolic calculations are really useful if you want to check any theoretical results, if you want to illustrate what you derived before in various proofs. I see you in the next one.